Is it because I already did one recording?
Yeah, you're recording.
There
It's
we go.
already
Oh,
recording.
okay, it's
recording.
All right.
It's already recording.
All right, good morning. It's Thursday, November 3rd. It's math time, and today's math lesson is 4.08. Let's go to that now. What I would like you to do is get ready to do the math with me. So please get out a piece of paper. And also, before I do that, let me stop the share. I noticed that Lauren and Eli are done, but I don't see Lauren here. Shoot, Eli, I was going to send you off to play a game with Lauren. I'll leave it up to you if you want to stay with the math lesson or if you want to go do your dream box. Eli, do you want to go do a dream box in a breakout
I'll do
room?
dream box. I did no box.
Okay.
If
I will
someone
set up-
finishes up their math, can you send them?
Actually,
Sure.
I'll go because I'm finished. I just wrote it down my notebook, whatever it's called.
Okay, well, stay with us and make sure your first one's right, then you can go to breakout room, okay?
Okay.
I'm gonna assign them manually, so I'll put our friend Eli into a breakout room. Let's see how I
Wait,
have,
so me and Lauren are the only ones finished with this?
yeah, well, it's today's lesson, so you really shouldn't be finished with it unless you're working ahead, so
I am working ahead.
that's fine.
I finished everything yesterday.
Okay, well, you can go into your breakout room and do your dream box. All right, everybody else. I can't get my cursor back. There it comes. Come on, cursor. There it goes. Let's share the screen and let's go. Everybody, you can go ahead and go on your own computers to lesson 4.08. Number Sense DC. The road trip's almost over. Harmony and her dad have only one more stop. Washington, D.C. Harmony has always wanted to visit the Lincoln Memorial. When she gets there, it's much bigger than she was expecting. In the last part of the journey, Harmony's dad teaches her how to use number sense to help her estimate when multiplying decimal numbers. And this is a really great skill because if you don't take a minute to sort of estimate and use your sense, you can come out with a crazy answer that doesn't make any sense at all. So this lesson is all about thinking about what your answer is going to be. And I have to tell you, today when I did the lesson, it really helped that I had done an estimate. Okay, I'm going to go on to the next page. I don't like it when it does this. Let's go back to this again and open it so that it won't be crazy. I don't know why it does that. It does that whenever I open it up too early. 4.08, Number Sense DC. There's an assignment for this one. You've got it in your workbook. There we go. What would you multiply 0.41 by? So the product is what the answer of a multiplication fact is called, is a whole number. Explain to a friend or family member. So right now, if you had 0.41, how many times would you have to multiply that by 10 to get it to be a whole number? So that means not a mixed number with a whole number and a fraction and a decimal, but a whole number. Anybody know right now how many times you'd have to multiply that by 10 to get that decimal moved over and make that a whole number?
Get times it by 2, like 2 tens.
2 tens, right? So each time you times by 10, that decimal point is going to move over. So you're exactly right, Liam. If I times it by 10, it's going to be 4.1. And if I times it by 10 again, it's going to be 41. Here's the answer. You would need to multiply 0.41 by a multiple of 10 to find a whole number. If we multiplied 0.41 by 10, this would give us 4.1. This still has a digit in the tens place, so it's not a whole number. If we multiplied 0.41 by 100, which is 10 times 10, this would give us 41. This is a whole number because there are no digits after the decimal point. It's actually, it's still a whole number when it's 4.1. It's 4 wholes and 1 part, but we call that a mixed number. Harmony's dad explains that number sense is used as a way of estimating the answer before actually finding it. You use mental math to get a reasonable estimate to compare with your answer. Let's use the multiplication equation 3.2 times 4.6 as an example. First of all, focus on the whole number. We can focus on the whole numbers and use what we know about them to get us an idea of what the solution will be. 3.2 is rounded to about 3. 4.6, since the 6 is higher than 5, then that would actually be closer to, they say 4 here, but we know that rounding that you'd make it 5. So 3 times 4 is 12, 3 times 5 is 15. Your answer is going to be about 12 or about 15. Since the decimal parts of the equation are less than 1, we can confidently say that the product of the original equation will be close to 12. About 3 times about 4 equals about 12. It's going to be more than that because this is more than 3 and more than 4. So it's going to be between 12 and 15. Could use an area model to solve it. 3.2 times 4.6. Here's the 3. Here's the 0.2. Here's the 4. Here's the 0.6. Here's all 4 of our partial products. We line them up with the decimals carefully in the right place. I also made that mistake this morning when I was hurrying through my math. And I get an answer of 14.72. So actually, the answer was closer to our estimate of 15 than the book's estimate of 13. Ha ha ha, book. We knew more than you did. Okay, we use the area model. Try the next example. So right now I want you to estimate 8 times 1.2. What is that going to be about? Hold up the number of fingers you think the answer will be about. 8 times 1.2. I'm looking for some fingers or some things in the chat to show me what that is. I see 1. 1 times 8. If you have 8 cakes and you times them 1 times, you're going to come up with 1. There we go. 8. Now I'm seeing it and it's right here on the page, right? 1.2 is almost 1. Is it going to be more than 8 or less than 8? Our answer. You guys know, is it going to be more than 8 or less than 8? Because the real number here, is it 1 times 8 or is it a little more than 1 times 8?
It's going to be more than 8.
Yeah, it's going to be more than 8, the answer. So that's estimating. You know that it's going to be a little greater than 8. Let's check it out. 8 times 1.2, we split them up into the partial products. 8 plus 1.6 is 9.6. It was a little more than 8. Well done. The estimate we found using number sense was 8. We also decided it would be a little bit greater. The actual product was 9.6. Yes, Mila.
I kind of have a, do you teach the lessons for the kids who have trouble understanding the lessons, or is it for everyone?
You know, I usually don't teach the whole lesson, but recently I had it come to my attention that some people weren't reading and doing the entire lesson. So I'm kind of modeling how I expect you to work through the lesson when you do it. If you're already taking your time and doing it like this, and you'd like to go to a breakout room right now, I can send you there to do the problems.
Could I actually leave, because I normally am able to do these by myself?
Excellent. Go ahead.
Thank you.
All right. So page 3, Harmony is starting to get the hang of number sense. Here's some more examples to show how number sense can be used to make reasonable estimates. And like I explained to Mila, today I'm working through the whole thing the way I expect you to do it at home. If you stay with me, you'll have it done when you're done. Use number sense to estimate the product, then solve the equation. Now, if this was me, I did it a little different than they did it. They looked at 0.5 and they said, oh, that rounds up to 1. But I look at that and I say, well, that's about a half a cake, about 7 times, a little less. So if I had 7 halves of a cake and I shoved some of them together, that would make like 3.5 cakes, right? 7 halves, each 2 halves make 1 whole. So 2, 4, 6. It's about 3.5 cakes in my estimation. They're going to teach you to do it kind of more formally. 0.5 rounds up to 1. 6.7, they rounded down to 6, which I think is weird because 6.7 is really closer to 7. Anyway, 1 times 6 is about 6 cakes, they're saying. I think that's way too high. It's a half of a cake about 7 times, but whatever, that's what they say. This equation is a little different. And you guys are allowed to argue with the book if you think they're doing a poor job. We could round it to 0, and 0 times 6 is 0, but we know the answer is going to be more than 0. The other option we have is to round 0.5 to the nearest whole number. That would be 1. They think that's a better estimate to use. The other way is to look at this and understand that 0.5 is less than 1. We're multiplying 6.7 less than 1 time. You know the answer is going to be less than 6.7, right? Let's take a look at step 2. Here we break it up into 0.5 and 6.7. 5 times 6 is 30. We know 1 number is behind the decimal, so it's 3.0. 7 times 5 is 35. 2 digits are behind the decimal, so it's 0.35. We line it up, 3.0 plus 0.35, and we come out with 3.35, which was really pretty close to our 3.5 cakes, wasn't it? We did a better job than they did. Using number sense, we estimated that the product of the equation would be less than 6.7. We actually estimated it'd be about 3.5 cakes. The actual product was 3.35. This shows our estimate was correct and number sense works. But I will tell you this, if you made a little mistake and came out with 33 cakes, you could look at your estimate and say, oops, I either estimated wrong or I did my math wrong, because those two don't match at all. We're working hard to understand number sense. Number sense involves using all of the things you already know to make a good estimate so that you can check and make sure you're right. So everybody right now on a piece of paper, do a little estimate of this one, 0.6 times 0.49. What do you think it will be? Put into the chat what you think the answer will be close to. Oops, I'm going to put into the chat too. So take a look, put it into the chat if you can guess it. So 0.6 is close to 0.5, and we know that's a half, right? And 0.49 is really close to 0.52. So we're basically saying 1/2 of 1/2. So if I have a piece of paper and I fold it in half, now I have a half. And what is a half of a half? Oh, well, if I fold it again, guess what I have? About a quarter. Just like with money, in decimals, a quarter is 0.25. So I think the estimate's going to be pretty close to 0.25. They've estimated it to be less than 1/2. I think it's going to be closer to a half of a half. Let's see here. 0.6 times 0.4 is 0.24. 0.6 times 0.9, 6 times 9 is 54. I know that because 6 tens would have been 60 minus 1/6 is 54. Now I have to be very careful that I counted 1, 2, 3 numerals behind the decimal. So 0.054, that's tricky. So 0.24 plus 0.054 equals 0.294. Was that pretty close to 0.25? It was. Shows our estimate was correct and number sense works. And then they ask you to think about it a little bit, how strategies and methods are the same, and they have a big, long, wordy explanation that I don't think anybody really reads or pays attention to, but I'll leave it there for you to try. Stretch
Do we have to do the last question, question 5?
this one right here. Oh, which one?
No, for the workbook.
Well, yeah, you have to do all the questions, silly. So here's the worksheet. DC makes sense yet. It's this one right here.
It's not
You have
that.
to do all 6. DC makes sense yet. You can download it here if you want to, and then work on it online, or you can work on it elsewhere. It says right here that you need to use number sense and make an estimate first. So let me show you what it means by that. I'm going to just spotlight my screen and show you what I did.
There's a different one. There's a different one.
Yeah, isn't it number sense DC?
Yeah.
Yeah, no, DC. Yeah, but it's number sense DC, but the printable activity is DC makes sense yet.
No, my book says number sense DC.
Does
It's
it
for
look underneath it?
Huh?
Doesn't it say both titles?
No, it doesn't say both titles.
number sense.
Oh yeah, you're right. There's 2 of them. So this is a practice one. And then the other one is the real one, I guess. So they give you a practice one and a real one. So let's do this practice one together. I'm going to download it so I can edit it. And I'm going to share my screen. And you say, do you have to do it? Okay, that's interesting. So there are 2 worksheets. Good to know, you guys. So this is the practice one right here. I just downloaded it, but I think this isn't the copy that will let me work on it. So here, let's see if I can find it. Date added. How come it's not there? Come on, you. Where are you? Let's try again. DC makes sense. Oh, it's on desktop. That's why. Okay. Desktop. DC makes sense yet? Here it is. All right. So if I were doing this estimate, I would say to myself, 6.5 is just about what? What do you guys think? What is 6.5 close to? 7, yeah? So I'll take my text box and I'm just going to write a 7 in there. 7 times, what is 4.1 just about?
4.
4, right? So we are, Ms. Janney, we are just doing the practice sheet. So there's a practice sheet and a real one. And I would love it if you could go work on this with maybe Ms. Bree and Miss Amoy. Why don't the 3 of you go to one of the breakout rooms and
Okay.
start working on this? Can you, I think I might have to assign you to the breakout rooms.
Okay.
And then, Amoy, I'm having you do it because you've gotten a little bit behind in your math this week. And so I think that this will be good. You guys can work on this. I would suggest actually you go work on the other one, the actual assignment, which is a 4.8. It's called Number Sense DC. It's in their booklet.
And should we do that first or do this first?
Do the other one first. With
Okay.
But here's how you're going to do it. You're going to do an estimate. So 6.5 is close to 7, 4.1 is close to 1, and 7 times 4 is, guys, what is 7 times 4?
28.
28. So there's my estimate. Make sure that you've done an estimate. Mine, of course, is now in the wrong spot, but there we go. There's my estimate before you solve it for real. And then you're going to go in and solve it for real. And you can do that 2 ways. You can either do it just by using math, where you make a text box and you solve it. And they might be working on paper, which is also fine.
Uh-huh.
Or you can grab one of your pens. Hopefully I can grab a pen right now. And you can make a box for partial products. And you can separate it. Uh-oh, my box is not working right now. I'm not happy with my box. Okay. Well, I'm just going to show you here. So the other method they're using is the partial product method, where you draw a box and you separate the number into its place values. So 6 here and the 0.5 over here, and you draw a line, and then you do the 4 and the 0.1 here and draw a line, and then you do 4 times 6 is 24. Does that make sense? Am I still
I will learn it as we
The
go
answer is
along.
28.
Okay. I'm gonna transfer you guys to a breakout room to work on that.
Okay.
And the girls can
Wait.
help you.
Yeah, the girls are going to need to help me because it's not my strong suit. And so I'm going to just work with them, and they'll, teaching is the best way to learn. So.
Okay. Moy room 2 and Brianna room 2. All right. There we go. Uh-oh. I can't get you in there, Bree. There we go. Okay. Liam, did you have a question?
I think I got the riddle correct.
Oh, well, we'll do it later because right now you need to work on it, okay? So everybody on this DC makes sense. We've done our estimate. Now I'm going to use partial products. You can do it the way you like to do it. And I split the number up and I put it into the partial product method. So I drew a line and drew a line. I said 6 times 4 is 24. You can be filling this one out right now. I said 4 times 0.5 is 2.0. 0.1 times 6 is 0.6. And 0.1 times 0.5 is 0.05. Be careful with that one because there's 2 behind the decimal point. Then I lined my numbers up carefully with the decimals on top of each other and added it up. And I ended up with 26.65, which is pretty close to 28. So I checked that off. So you should be working on that one right now. Do I have any questions about how we're doing that one? Liam, I see your hand raised, but that was for the riddle.
I even looked it up. I even make sure.
Miss Laws,
Yes.
I sent you the email for the riddle.
Oh, okay, but not right now.
Also, I just need one more dream box to go to 12.
Okay, good. Go do it. Any questions about this one? So you can write down what I've got written on your page and make sure you've got this one done. Can I take it away yet? Are you guys done? Or still looking? I see a thumb down. People writing. I think we'll do number 2 together, and I'll share my whiteboard. You guys can help me with it, okay? So I'm going to go to the whiteboard and do number 2. Ooh, okay, let's see how this goes. So I'm just going to draw. It's going to be really sloppy. Actually, I'll start with the text box and put the problem up here. We need much bigger size, right? Okay, can you guys see that? Can you see my whiteboard right now? Yes or no? Yes? Okay. So number 2 says 9.3 times 0.3. So if it's me talking to myself, what I'm saying to myself at this point is, so 9.3 is like 9 big cakes, right? And instead of timesing them 1 time or even a half a time, I'm going to do it 0.3 times. That's kind of like 10. If I had 0.3, that's like 3 slices of cake, and I have it almost 10 times. So that's going to be almost 30 slices of cake is going to be my big guess. So if it were me right here, I would say 9.3 is sort of close to 10 times 0.3, which would equal 30, but it would be with 1 behind the decimal point like that, right? Because it's not 10 3 times, which would be 30 cakes. It's 10.3 times. So I'm going to have about 30 slices of cake, but I'm going to have to shove them together, and that's going to make about 3 cakes, isn't it? Because 10 pieces makes 1 cake. So 30 pieces of cake, or 30 tenths, is going to be about 3 cakes. That's my estimate. Okay. Now I got to solve it. So I'm going to go down here, and I'm going to grab myself a nice big box. And I'm going to write my numbers in it. Oh, that's a beautiful box, Ms. Laws. So up here, I'm going to write 9. That's 9 holes. And then I'm going to make a line. Beautiful. And then I'm going to do 0.3. Okay, there's my 9.3. And then, oh no, what am I doing? Yeah. And then I'm going to times it by 0.3. So over here, I just have one thing, 0.3. 3 times 9, what is that? That's like 3 tens minus 1 3. How much is 3 times 9? Somebody tell me. Who knows what 3 times 9 is? Come on, guys.
The,
Hold on a second.
What is 3 9s?
27.
It is 27. So, but it's not really 27, is it? Because we have one number behind a decimal. So we've got to count and put the decimal in. It's 2.7. What is 3 times 3? Christian? 3 3s.
2 3s is 6, and you have to add 1 more 3 to that.
And it is?
And
Yes.
0.9.
All right. Is it 0.9? How many are behind the decimal? 1, 2.
No.
So it's this is important, Kainoa, 0.09. You see that? Because it's not 3 tenths 3 times. It's 3 tenths of 3 tenths, right? So it's 3 tenths times 3 tenths. It's not even 1 times 3 tenths. So you know it's going to be smaller than 3 tenths. Now we have to add it up. 2.7. And I want you always to stack them because we have to keep it even. Put the decimal there. 0, 9. And if it helps you to add a 0 over here, it's perfectly fine to do that, right? Less. Now we just go straight down. 0 plus 9 is?
9.
7 plus 0 is?
7.
2 plus nothing is?
2.
2.
Now we check. Is 2.79 close to 3?
Yeah.
Yeah, it's really close. Excellent. We did well on that one, huh? Does that make sense, my friends?
Yes.
Okay, so you've got 6 of those to work on this worksheet. And then let's go look at the lesson one more time and make sure that we know exactly what we want to do. So, because I actually didn't catch that on the lesson, that it's a separate one. So that's a practice one, and it's got the answers. And then it talks about the summary, and there's a self-check to just make sure you understand it. And then what's my assignment? Number sense DC. Well, it is the same one. So that other one, that DC makes sense yet, I don't even know where that one is. Do you? Oh yeah, number sense DC. Oh yeah, that was just the practice one. So here's the number sense DC. And number 5 says, explain the relationship between a strategy such as number sense and a written method such as partial products for multiplying decimal numbers. If it were me answering that question, I would say that a strategy like number sense helps you check whether your answer is reasonable. Like, does that make sense? So for example, if a problem said that I have 3 times 1/2, and I think about it and I think, well, that's 3 halves. I can shove 2 of them together equals 1 and another one equals 1.5. Or if I'm using math and I make a little mistake and I know it's 0.5 times 3, I might come up with 15 and tell myself that the answer is 15. There's not 15 cakes. 3 times 1/2 is not 15 cakes. It's 1.5, right? So that estimate really helps me know whether my answer is reasonable. So if I were answering number 5, I would write something like that. And you just have 4 to do for your final answer, okay? All right, guys, that is it for the math problem today. You may go into a breakout room, do this math sheet, and then do a Dreambox lesson, or you may leave the meeting if you would like to and work on these things.
Bye-bye.
I know.
Bye.
Okay. Is your question, can you work with a partner?
Bye.
Hi. Is that your question?
Yeah.
You can. Does somebody want to work with Kainoa on this one?
I'll be his partner.
Christian?
Not
Christian, make sure you've opened up a times table and that you're working with that, okay?
Yeah.
Breakout rooms.
7.
Kainoa is kind of quick with his math back, so he's kind of got that one down. Okay, so room 7 you want? Why room
Yeah,
7?
I put 7 already. Bye.
Bye. Okay. Oh, he already put them in 7. Okay. Mama, do you have a question? Hey,
Nope.
I sent you a little note because I was worried about your mom bringing you, if you come tomorrow on the bus, would she have somewhere to hang out? And they said she can hang out inside Flex in the lobby while you're at Flex if she wants to. Okay?
All right.
All right. You can tell her that. All right. Well, you can go do your math. I know you're pretty good at getting your math done.
All right. I'm just waiting to be